So I'm not going to take too long on the review, but I want to get your minds. You guys have been thinking about all these different things and everything. So we're just getting your minds back into higher order functions. We talked about how higher order functions are part of array.prototype. So array.prototype.map is a function. Array.prototype.filter is a function. These are methods that live on top of the prototype of arrays. They are power tools, like power drills that we use to achieve and accomplish certain methods. Why are higher order functions important? They're important because when you get to React and we start working on other teams and software, everybody uses higher order functions now. And so getting to know them will help associate you with them. We talked about two higher order functions yesterday, map and filter. Map, we said it always returns the same number of elements. So if we say let new data equal data.map, it takes a function, and then the function takes an argument which represents every member of the array that you're looping through, the contents of that member. So let's just say this is num, and we want to return num times 2. This was the example that we did yesterday. So here we have data, and then we're defining a new variable called new data, which is the original data, but we run it through a map, which is a special function that applies the rule to every single member in the function. This line here is our rule. Line 8 is our rule, so we're doing num times 2, so it should see everything here doubled. So if I come in here and I do this, then I get every number doubled, 2, 4, 6, because we started with 1, 2, 3, and that was our map. So we said map is a translation. Just like a Google map, it's a translation of a city. It takes everything in the city and it just takes, on a one-to-one basis, puts it all on a map. That's what map is. That's what map means. We also talked yesterday about filter. So a filter, if we wanted to filter out all numbers that were greater than 33, what would we put on line 8? Return
num greater than 33.
Yep, return num is greater than 33. So if we go back here and then we run this file, then we get 55, 77, and 1102. So we've written a map, and we've also written a filter. So these are really two very useful ones, and we also showed the fat hour because we need to show that. When you go out in the field and you work, a lot of times people just do this. Let new data equals filter num is greater than 33, and that's all she wrote. Same result, much cleaner, much faster. When you're in React, all your stuff is going to look like that. Map alone, I mean, you use map, seems like 70% of React components is mapping stuff. But when you map, you're doing stuff like you would in React. You do something like this, like map. Like if you want to map every number in here, in React it would look something like this. You'd be doing something like it would come out looking like this, like this. They use, we call a template literal, or some people call them template strings, H1, you know. So in React, we've just created a whole bunch of H1 tags, you know, and then so, you know, something like that. Or it would be a div, you know. But you use JSX in React, it creates all of these different DOM elements, so you like map through all the images, like on your Facebook feed. That could be a map, right? React comes from Facebook, right? So, you know, your feed might be a map of all the images, and so it's like, yes, there's this image URL, but it needs to be wrapped around pretty stuff like an image tag, and then it needs to have a link So there might be an A tag. All this stuff is mapped out for you and then put into the DOM. So that's where this stuff comes from. So we talked about map and filter, and so now what we want to talk about is reduce. So reduce is probably my favorite of all the higher order functions. It's also the most complicated of all the higher order functions because it requires you to just think a little differently than all the rest of them. And I'm going to start off with a simple array of 1, 2, 3, and 4. And we're going to use reduce. So what is reduce? My favorite definition of reduce came from John Armbruster, who actually is one of my instructors in Phoenix. And you know, when I explain reduce, typically I like explain it in like 3 sentences. And he came out with the best. It's funny because it's almost like he called array.prototype.reduce to actually come up with the definition for reduce. Because he reduced my 3 sentences down into one thing. He said, reduce just takes a number of values and then reduces them to a single value. Easy way to think about reduce. So you have a number of things. So the thing is that reduce, and some of you have used reduce. Trey asked a question about reduce on the queue today, right?
That was me.
Oh, that was you. Is there another Trey in here? There's another Trey. So his twin asked a question about reduce on the queue today. I didn't get a chance to get down to him. But reduce can get very complicated. You can use reduce to reduce strings. You can reduce objects. You can reduce arrays. It's whenever you have this whole bunch of things and you're reducing it down to a single value. So what I want to show you now, and you have this recording. It looks like it's actually recording. What I want to show you now is I want to show you how to do the number way when we're just using an array. And then I'm going to show you different versions of reduce. If you have it on the recording, you can go back and look at this when you need to look at this. But reduce is the master of all power tools. Like, I don't know who makes the best tool, if it's Black & Decker or whoever else makes the best drill, but reduce is he's the baddest boy on the block. Okay, so let's just talk about these numbers here. So we'll say let new data, again, equal data.reduce function. Now, this one is a little different. Reduce takes up to 4 arguments. Reduce takes up to 4 arguments. Those arguments are an accumulator, a previous value, an index, and an array. It takes up to 4 values. An accumulator, this is a typo here, I'm sorry. An accumulator, a current value, not a previous value. An accumulator, a current value. If you took notes, please change the second one. It should not say previous, it should say current. An accumulator, a current value, an index, and an array. What do all these things mean? Well, we'll start off by, I showed you all of what it can take. I'll show you what most people use it for. Most people only use the first 2 values, which are the accumulator and the current value. So, well, what's the accumulator? This is a loop, and check this out. Reduce, it basically is a way, it's like a rolling snowball. And so it takes whatever was in the snowball, and then you return what's currently in the snowball, on your stage, into the snowball. So in order for a snowball to work, you need to start off with some snow. So what it does is it starts off with the second element, and then what's in the first element is part of the snowball. So what it does is it says, okay, I want to reduce through these numbers. So you need a current value and you need a previous value. That's your snowball. So the current value when it first starts looping is 2. And what's in the accumulator, the snowball, is 1. So what I'm going to do is, whatever you return is what is the new stuff that gets wrapped into the snowball. So if I return the accumulated value plus the current value, what happens is, when I first go in, my current value is 2, my accumulated value is 1, right? So 2 plus 1 is 3. That's the new snowball. That's the ACK is our snowball. You see, that's our snowball, right? So then the next time it loops, our current value is 3. So let's keep track of this. I'm just going to put some notes up here. So the first time we loop, our current value is 2. The snowball is 1. So 2 plus 1 is 3, because that's what we're returning. That's the new snowball. So that's the snowball, is 3.
So it's like getting the sum of the array.
Exactly. That's what it's doing. But I want to talk about the process, because when you start using strings and objects, you really need to start thinking in terms of this snowball, because it's not always going to do the same thing. So then the next time we loop, the current value is 3. What's in the snowball? 3. So we're doing our current value, which is 3, plus the snowball, which is 3. And so then now it's 6. This is our new snowball. And lastly, our current value is 4. And what's in the snowball? 6. So when we run this, oh, hold on, I didn't save. When we run this, our value is 10. So we just use reduce to basically, as Austin said, sum up all of the numbers in an array. So this is super useful. Like anytime I have a whole big ton of array of stuff, I use reduce to just sum up the values. So you can use any number of values in here. And we'll take all of those numbers, and it gives you a total. Super is the fastest way to total up a sum of numbers is using reduce. Any questions about that?
Yeah, I'm just confused on what all is being added each time the accumulator and current value. You're adding the number that the index would be.
There's no index here. There's no index here. You could have an index. You could add index as an optional value here, but we're not using that now. We're just using the accumulated. It threw me a loop for the first time I saw this. I actually had to take a pause. I was like, oh, hold on. What's actually happening here? So what it's doing is it's a loop. It goes in, it skips the first one. It goes in on this one, and then it does whatever the rule is. So, and then that becomes the new accumulated value. So it actually might help me. It might help me if we use like strings to even show the next example, because it might help you see how that accumulator works. But yes, sir.
So it's not necessarily required to pass in the initial value of your accumulator after your function?
It is not required. So he's raising a very good point. So there is an optional first, if you want the snowball to exist, and if you want to start looping with this guy and you need a snowball to work with, you can pass the snowball right here. This is now the first value is 10. So we start off with 10, and then we say, well, 1 is our current value, and 1 plus 10 is 11, and then we get 2 plus 11 is 13, plus 3 is 16, plus 4 is 20. So then this, when you run this, you get 20. So this is, for some of you, it might have been like, oh, God, I almost was understanding what you were just talking about, and now, like, everything just totally jacked up.
So it'd be like if you had a function that like took an array, you did a for loop, you like had a variable called total, maybe total plus equals array I.
Yes, it's like plus equals. But that's just this example because I chose to, in my accumulator, I chose to do that. But let me show you another way that we use reduce, okay? Another way that you could use reduce. We could say let letters, let me do this. Let words equal the quick brown fox is a cat. The quick brown fox is a cat. So I got words. I'm going to do a reduce on this. And let new data equals words.reduce function accumulate current. I'm going to put an if statement in here. If current.length is equal to 3, then return the current plus the accumulator.
I have a question about that.
Yes.
If you're starting starting from the first,
Yeah, we would skip the word the.
so how do you make it start at index 0 for your...
You could do that. So, so what this is, this says, hey, I want a snowball to start off with, so I'm going to give a snowball of an empty string, and then it allows me to start with the word the, and the is my current, and then everything else works. So now, if I run this, I get cat undefined. Oh, all right, because else, we'll do an else here, return an empty string. Because we have to return something in order for the accumulator to keep working.
Should it be accumulated plus the current?
Oh,
Yeah.
yeah, right, I'm sorry. Return, this is a perfect teachable moment, right? So, if the length is 3, see what happened here is we got we got cat, right? Because if the length was 3, you want to return the current plus the accumulator. Otherwise, you just want to return the accumulator. So that just keeps the stuff in the ball already rolling. Otherwise, you're just returning an empty, you're deleting what was in the accumulator before. Then we get cat, fox, the. So let me talk my way through this. I don't want you to, don't get discouraged, just listen. What we're saying is, okay, we've got a snowball and then we've got like a current rule of what's going to go into the snowball. So we start off with a snowball that's just an empty string. And then we loop. And our current value, so when we first looping, the current is the. The current is always the current thing you're looping through. And that's just, this word cur here is not special. I just chose it to be the current thing that you're, some people put a C in here, some people write out the word current. But I just use cur to be the current value. So if the current dot length equals 3, so right now we start, is this one, does that length equal 3? Yes. So we're going to return the accumulator, right? We'll return the current value, which is the, plus our accumulator, which is just an empty string. So what's in there now is the word the, plus an empty string, which is nothing. Next one, quick. Quick is our current. Is quick.length equal to 3? No. So what do we return? Just the accumulator, which is our snowball, what's in it? The. Very good. Is brown, we loop again, is brown.length equal to 3? No. So this line fails. We go here, we return the accumulator. What's in the accumulator? The. Is fox equal to 3? Yes. So we return the current value. What's the current value? Fox, because we're looping through fox. Right, so we return fox plus, what's in the accumulator? The. So then now our snowball has fox the. Now, is equal to 3? No. Is A equal to 3? No. Is cat equal to 3? Yes. So we return cur, which is what? Cat, plus what's in the accumulator? Fox the. So it should be cat. And we got cat fox the. Now that should probably make a little more sense.
Kind of like plus equals in some loops.
Yeah, but it's not plus equals because we're taking two things from two different places. We're getting our snowball and we're hooking it on with the current. I mean, so you could say return. No, I want to show. Let's just stick with cur plus ac because the plus equals is doing another.
I was trying to abstract.
Oh, you're thinking that? Yes.
Yeah.
Oh, yeah. Absolutely. And what you're doing is correct, right? Because when we talk about learn to learn is that you learn new things based on building neural pathways. And there's a school in education we call constructivism, which constructivist thinking means that you build bridges of knowledge based on the existing roads in your mind. So when you say plus equals, that's tying that bridge for you in your mind. So you should absolutely, what's your name? Mark. So you should be doing what Mark is doing. Whatever structures in your brain are connecting to this, allow that connection to happen, because that's when it's going to help you to understand this. I'm going to stop this recording.